Good day, everyone. We are Group 2, and we are going to discuss the chapter of supply chain operations, making, and delivery. Objectives: exercise an executive level understanding of operations involved in the categories of making products and delivering products. 2. Assessing supply operation in your company that may be candidates for outsourcing. Many companies and the supply chains, they participate in serving customers who are growing more sophisticated every year and demanding higher levels of services. Continuous improvements to the operation described in this chapter are needed to deliver the efficiency and responsiveness that evolving supply chain required. Product design. Product designs and selections of the components needed to build these products are based on the technology available and product performance requirements. Until recently, little thought was given to how the design of a product and the selection of its components affect the supply chain required to make the product. Yet these costs can become 50% or more of the product's costs. When considering product design from a supply chain perspective, the aim is to design products with fewer parts, simple designs, and modular construction from generic sub-assemblies. This way, the parts can be obtained from a small group or preferred suppliers. Inventories can be kept in the form of generic sub-assemblies at appropriate locations in the supply chain. There will not be the need to hold large finished goods inventories because customers' demand can be met quickly by assembling final products from generic sub-assemblies as customer orders arrive. The supply chain requires to support a product is molded by the product's design. The more flexible, responsive, and cost-efficient the supply chain, the more likely the product will succeed in its market. Product design choices includes component selection, should consider the supply chain impact, aiming for simplicity, fewer parts, and modularity to reduce cost and increase efficiency. For example, Company A versus Company B. Smartphone production. Company A makes a fancy smartphone with lots of cool features like a top quality camera and fast charging. To do this, they need parts from 10 different suppliers. The phone is a hit, but if even one supplier is late, the whole production stops. They have to keep extra parts in storage just in case. When one supplier stops making an important part, they have to redesign the phone, causing delays and lost sales. Company B makes a simpler smartphone with fewer features. There are only 3 suppliers for the main parts. Their phone isn't as advanced, but it's cheaper and it's easier to make. They don't face as many delays because they manage fewer suppliers. They always have stocks available in store. In results, a Company A struggles with delays and redesigns, while Company B takes over the market with a reliable, simple phone that's always available. What can we learn here? Product design defines the shape of the supply chain, and this has a great impact on the cost and availability of the product. If product design, procurement, and manufacturing people can work together in the design of a product, there is a tremendous opportunity to create products that will be successful and profitable. There is a natural tendency for design, procurement, and manufacturing people to have different agendas unless their actions are coordinated. Design people are concerned with meeting the customer's requirements. Procurement people are interested in getting the best prices from a group of pre-screened preferred suppliers. Folks in the manufacturing are looking for simple fabrication and assembly methods and long production runs. Collaborating across design, procurement, and manufacturing teams during product development can optimize the supply chain, leading to lower cost, faster time to market, and a more competitive product. Cross-functional product design teams. A group of people with a variety of expertise who come together to achieve a common goal. Representatives from these 3 groups have the opportunity to blend the best insights from each group. Cross-functional teams can review the new product design and discuss the relevant issues. At the same time, they are reviewing product designs. A cross-functional team can evaluate existing preferred suppliers and manufacturing facilities. A product design that does a good job of coordinating the three perspectives, design, procurement, and manufacturing, will result in a product that can be supported by an efficient supply chain. This will give the product a fast time to the market and a competitive cost.
Production scheduling allocates available capacity, equipments, labor, and facilities to the work that needs to be done. The goal is to use the available capacity in the most efficient and profitable manner. The production scheduling operation is a process of finding the right balance between the several competing objectives. High utilization rates, this often means long production runs and centralized manufacturing and distribution centers. The idea is to generate the benefits from economic of scale. This means producing a lot at once, using centralized factories and distribution centers. Low inventory level, this usually means short production runs and just-in-time delivery for the raw materials. The idea is to minimize the asset and cash tied in inventory. The approach is keep inventory small, with company producing in short bursts receiving raw materials only when needed. High level of customer service often requires a high level of inventory or many short production runs. The aim is to provide the customer with quick delivery of products and not to run out of stock of any product. To ensure fast delivery and avoid stockouts, company may need to keep more inventory and do smaller frequent production runs. When a single production is to be made in a dedicated facility, scheduling means organizing operation as efficiently as possible and running the facility at the level required to meet the demand of the product. When several different products are to be made in a single facility or on a single assembly line, this is more complex. Each product will need to produce for some period of time and then will be needed to switch over the production for the next product. The first step in scheduling a multi-product production facility is to determine the economic lot of size for the production runs of each product. This is the calculation of much like the EOQ or the economic order quantity calculation used in inventory control process.
Now let's talk about what is economic order quantity. It is the ideal order quantity to minimize inventory costs such as ordering costs and carrying costs. For example, you are selling burgers and you need raw materials such as buns, patty, cheese, and condiments. When you purchase these raw materials, there is ordering cost. It includes the processing fee and the transportation fee when delivering raw materials to your store. On the other hand, when the raw materials are delivered, carrying costs occur. It includes the storage-related costs like electricity and maintenance of the freezer and the wastages of storing the materials. If you will order frequently with small quantities of raw materials, carrying costs will go down but ordering costs will go up. On the other hand, if you order in bulk, ordering costs will go down but the carrying costs will go up. With EOQ formula, managers or owners can determine how many times should order in a month and how many quantities of raw materials should be ordered to minimize inventory cost and balance ordering and carrying cost.
Once production quantity have been determined, the second step is to set up the right sequence of production runs for each product. The basic rule is that if inventory for a certain product is low relative to its expected demand, the production of this product should be scheduled ahead than the other products that have a higher level of inventory relative to its expected demand. A common technique is to schedule the production runs based on the concept of a product's runout time. The runout time is the number of days or weeks it would take to deplete the product inventory on hand given the expected demand. The runout time calculation for a product is expressed as R equal P divided by D, where R for the runout time, P for the number of units of product on hand, and D for the product demands in a unit for a day or week. For example, let's say in Kimberly's cookies business, she still have a 200 cookie pieces on her hand. And her cookies demand for a day is 50 pieces. So you are going to divide the 200 pieces of cookies divided by 50 for the demand each day. And it means the product will run out in 4 days. The scheduling process is a repetitive process that begins with a calculation of runout times for all products. There are values. For example, EJ owns a snack business, the chips, cookies, and candies. The runout time or the R value of each product is 2 days for his chips, 1 day for his cookie, and 3 days for his candies. He will start his production with his cookies because it has the lowest R value. After his production, he will update the R value of his product. Now, for his chips, he has 2 days, 4 days for his cookies because he just produced more cookies, 3 days for his candies. For his next production, he will produce more chips because now it has the lowest R values. Keep checking and producing the snacks uh, with the lowest R value and checking the inventory to adjust the production count for the next production of your product.
Facility management make. All facility management decisions happen within the constraints set by decision about facility location. It is usually quite expensive to shut down a facility or build a new one, so companies live with the consequence of decision they make about where to locate their facilities. Ongoing facility management takes location as a given and focuses on how best to use the capacity available. This involves making decisions in three areas. 1. The role each facility will play. 2. How capacity is allocated in each facility. 3. The allocation of suppliers and markets to each facility. Facility management encompasses the planning, coordination, and management of physical space and service to ensure that buildings and environments are safe, efficient, and conducive to productivity. It involves maintenance, space utilization, safety regulation, suitability efforts, and supportive service, all aimed at enhancing the overall experience to occupants and optimizing organizational performance. Example, an example of facility management is a facility manager overseeing a corporate office building. This includes maintaining HVAC system, managing cleaning service, ensuring compliance with safety regulation, optimizing space usage, and coordinating renovation or repairs to create a productive work environment. Location. Where a facility is built affects management decision changing. Location is expensive and complicated. Location. In facility management, location refers to the specific physical site or geographical area where a facility or property is situated. It encompasses the buildings, infrastructure, land, and surroundings that the facility manager oversees. Managing the location involves optimizing space, ensuring safety and security, maintaining infrastructure, complying with local regulations, and supporting efficient operation within that physical environment. Key points in each areas. The role of each facility. Decide what each facility will do. This impacts how flexible the supply chain can be. In facility management, each facility plays a role based on its purpose and function within the organization. Facilities may include buildings, equipment, infrastructure, and system, all of which contribute to the overall efficiency, productivity, and safety of the organization. Below are key types of facilities and their roles in facility management. How capacity allocated in each facility. determine how much work a facility can handle. Too little capacity means missed sale, too much leads to wasted resource. Capacity allocation. Office space allocated based on the number of employees. Departments and function workstations, meeting rooms, and common areas are designed to maximize productivity and comfort. The allocation of supplies and markets to each facility. Choose which supplies and markets each facility serves. This affects shipping costs and the ability to meet customer needs. Location matters. The Bulacan facility is close to suppliers of bike parts, while the Pampanga facility is near to customers. Moving either facility will be cost. 1. Location matters. Bulacan facility proximity to suppliers allows for quick access to bike parts, enhancing production efficiency. Pampanga facility closer to customers which minimize shipping times and cost improving customer satisfaction. 2. The role of each facility. The Bulacan facility focuses on assembling bike while the Pampanga facility handles distribution. This specialization helps each facility operate efficiently. 2. Role of each facility. The Bulacan primarily focuses on assembling bike. This specialization allows for streamlined operation and increased productivity in assembly. Pampanga handles distribution, ensuring timely delivery to local markets. This role supports the overall supply chain efficiency. 3. How capacity allocated to each facility. The Bulacan facility is set up to assemble 500 bikes a day. If demand increase and it can only produce 400 bikes, they lose sales. If they try to produce 600, they might waste resources. 3. Capacity allocation. Bulacan capacity is designed to assemble 500 bikes per day. Challenge of increased demand. If demand rises to 600 bikes and production is limited to 400, the company risks losing sale. Risk of overproduction. Attempting to produce more than capacity could lead to waste resource and efficiency. 4. The allocation of supplies and market to each facility. The Bulacan facility works with suppliers who provide parts quickly. The Pampanga facility targets local markets to reduce shipping time and cost. 4. Supplier and market allocation. Bulacan suppliers work with suppliers that provide quick deliveries of parts essential for maintaining the assembly line without interruption. Pampanga. Market focus on local market to minimize shipping costs and time, enhancing service delivery and customer reach.
Order management delivery. Order management delivery is the process of passing order information from the customer back through the supply chain, from retailer to distributor, to service provider and producer. This process also includes passing information about order delivery dates, product, product substitutions, and back orders forward to the supply chain to customers. This process has long relied on the use of the telephone and paper documents such as purchase orders, sales order, change orders, peak tickets, packing lists, and invoices. Order management. Order management involves transferring order information from customer through the supply chain, including retailer, distributor, and producer. It also communicates delivery dates, product substitution, and back orders back to the customers. This process relied on phone calls and paper documents like purchase order and invoices. Order management in the deliver phase focus on the fulfilling customer orders efficiently. Key components include order processing. Once a purchase order is received, it's processed to confirm details, stock availability, and payment. Order processing. It begins when the purchase order is received and involves verifying the order details, such as product satisfaction and quantities. and the system checks stock availability to ensure the request items are inventory. Payment is confirmed before the order and approved for fulfillment and shipment. Inventory management. Monitoring stock levels to ensure timely fulfillment. This includes reordering from suppliers as necessary. This is the process of monitoring stock levels to ensure products are available for timely order fulfillment. It involves tracking inventory, assessing demands, and reordering from suppliers when stock runs low. Picking and packing. Orders are picked from inventory, packed securely and labeled for shipment, often generating packing lists and shipping labels. Shipping is ensure customer satisfaction by providing timely updates and ensuring that orders arrive in good condition. Shipping, coordinating with the carriers to deliver orders to customers. This involves tracking shipment and managing logistics. Order tracking, providing customers with the tracking information, enhancing transparency and communications. Order tracking provides customer in real time, informing about their shipments, allowing them to see the current status and estimated delivery time. Return management, handling returns or exchange efficiently, including processing returns, authorization, and restocking items. Return management, this ensures a smooth experience for customers and maintain accurate stock levels for future sales.
Order management is the process of receiving, tracking, and fulfilling orders. This process not only has financial implications, it also impacts the overall customer experience. Order management starts once an order is placed and continues as the merchant receives, accepts, and fulfills the order, which includes picking, packing, and shipping the order, as well as tracking the order until it reaches the final destination. Returns and exchanges are also part of the order management process. Automating order management processes can save time and money and ensure orders are delivered quickly and accurately, leading to happier customers and therefore helping drive profitability.
Entering the order once and only once. Capture the order as similar as possible to the original source remotely. Do not return the order manually. You should input the order just one time and accurately as possible based on the original request. Avoid entering it again manually. Automate order routine. Send orders immediately to the convenient delivery point. People only handle exception. As soon as you get an order, send it directly to the best delivery location. People should only get involved if there is a problem. Make order status visible. Allow customer and service agent to immediately view the details on the order status if they choose to. Make sure customers or service agent can easily check the order details and see where it stands at any time. Use integrated order management system. To protect data integrity, associate order management system electronically with other similar systems. Connect your order management system with the other related system electronically to keep your data accurate and secure.
Delivery scheduling. The delivery scheduling operation is of course strongly affected by the decision made concerning the modes of transportation that will be used. The delivery scheduling process works within the constraints set by transportation decision. For the most modes for transportation, there are two types of delivery methods: direct deliveries and milk run deliveries. Delivery scheduling. This refers to the process of setting the dates and times for delivering products to customer. This process is heavily influenced by decision regarding the methods of transportation to be used. Direct deliveries. Direct deliveries are deliveries made from one originating location to one receiving location. With this method of delivery, the routing is simply a matter of selecting the shortest path between the two locations. The advantage of this delivery method are found in the simplicity of operation and delivery coordination. Since these methods moves product directly from the location where they are made or stored in inventory to a location where the product will be used, it eliminates any intermediate operation that combine different smaller shipments into a single combined large shipment. Direct delivery. Products are delivered directly from the source to the destination. Milk run deliveries. Milk run deliveries are deliveries that are routed to either bring products from a single originating location to multiple receiving location, or deliveries that bring products from multiple originating location to a single receiving location. Scheduling milk run deliveries is a much from complex task than scheduling direct to deliveries. Decision must be made about deliveries quantity of different products, about the frequency of delivery, and most importantly, about the routing and sequencing of pickups and deliveries. Milk run deliveries. A delivery method used to transport mixed loads from various suppliers to one customer. It can also be used to describe a transportation route that has many stops. The advantages of this method of delivery are in the fact that more efficient use can be made of the mode of transportation used, and the cost of receiving deliveries is lower because receiving location get fewer and larger deliveries. There are two main techniques for routing milk run deliveries. Each routing technique has its strengths and weaknesses, and each technique is more or less effective depending on the situation in which it used and the accuracy of the data that available. Both of these techniques are supported by software packages. The two techniques are the savings matrix technique and the generalized assignment technique. The saving matrix techniques is the simpler of the two techniques and can be used to assign customers to vehicles and to design routes where there are delivery times, windows at receiving location, and other constraints. The generalized assignment techniques is more sophisticated and usually gives a better solution than the saving matrix techniques when there are no constraints on the delivery schedule other than the carrying capacity of the delivery vehicle. The disadvantage of this technique is that it has harder time generating good delivery scheduling as more and more constraints are included. This technique is best used when the delivery constraints are limited to vehicle capacity or the total travel time. Delivery sources. Deliveries can be made to customers from two sources: single product location and distribution center. Single product location. These are specific locations where products are either directly made or stored, such as a factory or a warehouses. Distribution center. This is a facility or location where products are sorted, stored, and consolidated before being distributed to various stores or destinations. The distribution center plays a crucial role in a supply chain management to ensure that products are delivered to their destination efficiently and effectively.